Yes, sir. Sorry for the interruption. Now we can start.
Okay, all right, I'll start again.
Yeah, thank you.
So welcome to lecture 4. In today's lecture, I'm going to talk about blockchain research areas. So if you are researching or doing your PhD or MPhil in the area of blockchain, this will give you some directions of what you can research. These are my areas, but there are many other areas in blockchain that are open and ripe for research. Next, I'm going to talk about 12 blockchain projects that I have led and delivered it with my team. All these are real-world blockchain projects for real clients. All the clients are based in Australia. So with these projects, you can get an idea of the types of applications that blockchain can be used for and the real world experience that I have gathered by conducting these projects or delivering these projects. So if you look here, the blockchain research areas. So BRDL here stands for my lab. So the research areas that we investigate or we study here are blockchain interoperability, and that refers to how we can make different blockchains interact with each other. And I will talk about that topic tomorrow in the last session. Next is blockchain adoption in organizations. So one thing that we have seen quite a lot with the technology adoption is that companies or users are a bit cautious or a bit, they're not very comfortable trying a new technology right away. So what are the challenges with adoption of a new technology like blockchain within organizations? So that is another area that we research on. And I have a PhD student who is just about finishing on that topic. Next, we work extensively in supply chain and blockchain, and we have developed multiple real-world projects that I will discuss today in this lecture. Other than that, we have also studied smart grids, energy informatics, and blockchain. And I guess some of you are working in this area of smart grid and power grid. So I think it will be useful for you to, if you're in this space, then I think it is a good area for research as well. Next is a strategic mineral traceability using blockchain. So this is again a supply chain use case where we have built a blockchain traceability solution for the mining industry. Next, and associated technologies that go around with blockchain are Internet of Things, IoT, data cleansing. So these two things kind of go hand in hand in any project where we are using blockchain and we are using automated ways to capture data. So through IoT. Next, we also look at blockchain and information technology risk. So risk management is a way on how blockchain can help organizations to manage their risk or mitigate their risk. And this is a very management or information systems related research area where you can understand what is it that you can do to ensure that you reduce the risk associated with compliance or your data management. Next is self-sovereign identity on blockchain. This is a very hot topic at the moment because there is a lot of data breaches that happen all around. There are a lot of breaches, data breach, identity breaches that happen around the world. And getting or having possession or being in control of your own data or your own identity is very important. So self-sovereign identity on blockchain is a very relevant use case. Another thing that we're also looking at is online monitoring or online advertising monitoring via blockchain. And this is a very practical use case because This is a very practical use case because a lot of advertising dollars are spent online. People advertise on Google, on YouTube, on Facebook, on LinkedIn, and a lot of other online platforms. But the advertisers who advertise on these platforms do not have a clue or cannot verify who these ads are shown to. Okay, so it may we at the moment we just trust the advertiser to advertise and show the ads to the right audience, but there is no way to kind of verify or prove that. So in that space, this is a very interesting use case where identity of the consumer or the one who is looking at the ads and the actual ad, it can be recorded on the blockchain. So the advertisers will have a strong verification and trust in the advertising network. Over the last couple of years, I have published, just not me and my team have published a number of research papers in top journals in blockchain and in different areas of blockchain. So here you can see on the left, reviewing the opportunities, challenges, and future directions for digitization of energy. So this paper looks at, first of all, this is on energy or smart grids, and then the technologies that are used for digitization. So in this case, we looked at Internet of Things and blockchain. So if you are in this space, researching in this area, I would recommend you read this paper. It's a very good quality paper. It's very thorough and very extensive. So do spend time to read that. Next is a paper that we did for blockchain and tax management. So this was published in Australian Tax Review, which is again a Q1 journal. The third paper was published on agriculture prosumer community groups using blockchain. So this was one of my PhD students who did her research in this space. And this was also in a Q1 journal. Next was health records or healthcare or interoperable healthcare and blockchain. So this was another paper also published in a top ranked journal. So as you can see, there are all four, in this case, there are 4 different industries or application or sectors where we have looked at how blockchain can be useful. So these are the 4 research papers. And within most of these research papers, if you would review the last section, which is on future research directions, you will see a lot of potential research directions that I have mentioned in that. And that will be a good direction for you to explore or pursue your research in that space. Other than that, there are another 4 or 5 papers that are currently under review this year. So they should be ready or published by early next year. So they are again on various aspects of blockchain. Okay, so I hope that gave you a little bit of idea on the kind of research that can be done with blockchain technology. Most of my research has been very industry focused and practical and applied, but there is also equal opportunity in doing core fundamental technical research on blockchain technology. And this is around improving the technical hurdles or technical challenges with blockchain. For example, scalability is probably one of the challenges that many blockchain platforms face. Or security, privacy. There are a lot of areas in terms of blockchain where we can study or research those aspects. Okay, now I would like to discuss various projects on where we have used blockchain technology, where we have developed an actual blockchain platform, and where these solutions are now used in the industry. Okay. So the project 1. So the first project, this was for an underground mining company where we worked on using Hyperledger Fabric as the private permissioned blockchain, and to track the complete end-to-end mining process, underground mining. So wherein you dig under the ground and mine, not over the ground. So this is also a bit challenging kind of mining activity. So what the client wanted here was to integrate blockchain to an existing ERP software, which is called as Pronto. So Pronto is the ERP software that that many mining companies use in Australia. And the idea was to explore how Pronto was to understand and to develop a layer or a middleware or a connector that can connect the Pronto software to Hyperledger Fabric. So it is a kind of you can also think of this as an example of interoperability, because we already have one software, which is Pronto, and we have a blockchain, which is Hyperledger Fabric, and we have to connect those two. So any information that is captured via Pronto has to go to the blockchain, and any changes that we make on the blockchain or record information on the blockchain can also be sent back to Pronto. So that kind of interconnection, interoperability between these two platforms is very important and a very practical application. So here you can see the flow of the mining activity. So it starts from here on the very top left, and the next, all the different steps in the whole mining process you can see on this figure here. Okay, I'll now zoom it a little bit so you will be able to read it a bit more clearly. So I will not go through these different terminologies and words because they are very specific to the mining sector, but there is something that is called as a drill plan, which means, in simple words, where you need to drill to mine the ore. Then there is a concept of ring, holes, actual drilling, drilling, then long haul charge up, so on and so forth. So there is the whole process. And once this whole process is completed, we get three variations, or say three different variety or grades of the mined mineral. Okay, so if it is gold, there will be high quality, medium quality, and low quality. So there is, and the reason why this is there is companies who use whatever metal or mineral is mined, they need the ore to be a specific quality or specific grade. They don't want 100%. They maybe want 80% or maybe 70% and mixed with something else. And the reason for that is that is the composition that is required for that is the composition that is required for the product that they are manufacturing. So that's how the different grades of the ore is created. Okay, so in here, what is important to understand is all this information. So this all these codes are the codes that are used in that software, existing Pronto software. And this is how we identify. There's a lot of information that Pronto captures, but not all information is necessary for to be posted to blockchain. So what we do is we only select relevant information that is important from a traceability, transparency, and auditability point of view. And that information is then recorded and stored to the blockchain. So we have published a paper on this as well. You may want to check that because we explain this process in more detail there. Okay, now let's move on to project 2. And project 2 is in the agriculture supply chain area. So here we have built a product called as HiTrack. Here we have built a product for our client, and the product is called as HiTrack. And this is agriculture supply chain traceability platform using blockchain. Here again, we have used Hyperledger Fabric as our as a blockchain of our for developing this. Here we also built a mobile app and a web app. So the end users have access to both the platforms. They can use HiTrack using a mobile device or using a web app or on a computer. This is a website for the product, hitrack.io. If you want to check it out, you can check it out later. There's a lot of information there about the product. You cannot access the product because it is a exclusive paid service, but you can get an idea of what the product is and what all you can do with that product. Here you can see some screenshots of the app in action. Basically, what we are doing here is this platform was designed. This platform was designed for recording the or to keep track of hemp. Hemp is a crop which is grown here, and I guess in many other countries as well. So traceability of hemp was important for the government here, and they wanted to build a platform, and that's where we came in. So the HiTrack platform helps, or there are 4 main users for this. One is the license holder. Next is the farmers. The third is the regulatory body, which is the government, like Department of Agriculture. And then fourth is the testing agency. So all these 4 users can be considered as nodes in the blockchain because they will keep a record or a copy of the blockchain to be part of that network. So what does this software do? It has a 6-stage process, as you can see in this figure. So the first step is seed sourcing. Typically, the seeds, the hemp seeds, are imported to Australia from other countries. So the Australian quarantine body or the government department wants to keep a record of where all the seeds are coming to Australia and where are they, which farms they are going to. So that is the first stage where we help to record the seeds where they are coming from. In this case, when the seeds arrive at the border or at the customs, the department can there take a photo of the seeds, or they can take a photo of the invoice or the purchase order, and they can put that information to the blockchain using the HiTrack platform. Similarly, once the seed arrives on site at the farm, the farmer can do the same thing. They can take a photo, and they can also take a the farmer can take a photo of the seeds as well as the purchase order or the invoices or the delivery docket. What that does is, when they are taking the photo through the app that we have designed, the app captures the GPS coordinates of the photo, of the picture. So both the latitude and longitude, those are captured by the mobile device, by the phone, when you take a photo. So it is in a way providing some evidence that these seeds were on this platform, these seeds were on this farm on this day and time. So the location is captured, date and time is also captured. So that we are kind of building some history, a verified history. So starting from the border control to the farm, we have some information that is recorded on the blockchain in a immutable format. The next step is sowing the seeds for growing. Here also, we can take photos, we can take videos, we can put any other evidence. For example, if the farmer engages a laborer or a company that provides the services to sow the seeds, then they can put a record of the invoice that they may have received from that company as an evidence to put that somebody has come and has done the sowing. While the sowing is done, we can take video footage, we can take photos, and all our GPS geotagged. Next is the next is crop management. So crop management would be monitoring the growth of the crop, monitoring the health of the crop at different stages. So it could be putting the fertilizers, or if it is grown organically, then recording that there is no fertilizer that is used, and how much water was consumed. And that information about all the water consumption can also be recorded on the blockchain, because that is useful for showing the government or showing the relevant authority that how much water is being used for growing this kind of a crop. Next step is flowering and inspection. So this is where the testing agency is involved. So when the flowers starts to come on the crop, they need to be tested for 2 different chemicals, and this is a regulatory requirement. So a sample is taken from here and sent to the testing agency. Testing agency completes the tests and uploads their records to the blockchain directly. And finally, harvesting and cleaning is the next step, followed by drying and storage. So as you can see, the whole process, starting from getting the seeds to drying and storing the seeds, is fully recorded on blockchain. So this software or this blockchain platform was developed in association with Hemp Grow to address the challenges faced by hemp growers and regulators in the Western Australian market. So in this case, the platform is IoT enabled, which means if the farm has sensors on the farm, that means the farm is automated, then we can collect a lot of this information directly via sensors rather than manually putting it on. So you can also imagine a drone kind of flying over the whole farm, taking capturing the aerial view of the crop, and then coming to the docking station. The data automatically transfers from the drone to the edge device, and that is now connected to the blockchain. So the information can seamlessly be collected and posted to the blockchain. So in the end, what we try to achieve is get as much transparency and traceability in the whole process of capturing this data. And we are building a story, right? So what we try to achieve, what we want to achieve is a situation or a state where tampering of this information will become difficult, if not impossible. And tampering in a sense of fudging the information, right? Once the information is on the blockchain, you cannot tamper it. But what information goes on the blockchain is something that needs to be monitored. And there has to be some way to kind of prove that this is a timeline of activities that have happened. So if there is any form of audit later down the track, it can be, there is full evidence for the farmers to provide it to the respective bodies. All right, let's move to the third project. And the third project is the project on coffee cup provenance. And this is a very interesting project. The angle here is supply chain traceability, supply chain management. But what is the supply chain here? It is not the coffee supply chain. But what we are doing here is we are tracking the use of coffee cups. In Australia, when you go to a cafe, or even in India, when you go buy a coffee, the coffee is served in a paper cup, right? Which is a one-time use cup. So you have the coffee and then you throw that coffee cup. So in Australia alone, there are over 1 billion coffee cups that go to landfill each year. So you can imagine how much environmental pollution the consumption of coffee is creating, right? So when we work with this startup, you can see their tagline here is we are shifting consumption culture through design. Yeah, the website is ourkinds.com.au. You can check that out later as well. So what we're doing here is so first of all, we build a mobile app for them, of course. And the idea of the whole startup is they want to replace the concept of single-use coffee cup with a reusable coffee cup. So in India, as we see, whenever you go probably have a cup of tea in a restaurant, you often get the tea in a glass cup, right? But in here, it is not very common, that kind of a concept. So they'll always get a coffee cup in a single-use coffee cup type. So here what we want to do, or what the idea of the startup was, that instead of giving a coffee cup, which the consumer, the people will throw after having the coffee, this coffee cup can be reusable. Yeah, and what the main idea was that we still give this cup for free, so we do not charge anything extra for giving the user a reusable coffee cup, but we request the people, the coffee buyers, to bring that cup back next time when they come for a coffee. And typically, when you go get a coffee, it is you go to your common coffee shops which are close to you, and you will always get the same. So it is possible for you to kind of return the coffee cups. And so we run a test experiment here. So we started with 300 reusable coffee cups, and we ran the experiment for 5 weeks, and we were able to save 6,000 cups from going to landfill, right? But then we continued that and we saved 12,000 cups. So you can see, like, every cup was reused 40 times. Yeah. And not only that, it is just a matter of changing the user's habit on how they consume coffee. So they're still getting the coffee, they're still getting a cup. The only thing is we are asking them to bring the cup back next time they come. And very interestingly, we found many coffee buyers, many users, people, they came to the coffee shop and then they said, oh, I forgot to bring the coffee cup back. And can I bring it tomorrow? Then we said, okay, that's fine. So we gave them another coffee cup. And the next day they come and they say, oh, again forgot. And then we gave them another coffee cup. And in the end, there were many customers like these who, towards the end of the week, they kind of stacked their whole set of cups and like gave us back, okay, these were the 5 or 10 cups that we used from your coffee shop this week. So have them back. So people are, it is changing the culture and people are appreciating that. So, but where is the blockchain coming in this picture, right? I explained you the whole process of what we are trying to do, but where is blockchain? So in this case, you can see here, under each coffee cup, right? We are putting a small QR code, a round QR code which goes under the coffee cup. And every time the coffee cup is reused, we scan the coffee cup using this mobile app. So just using the phone camera, we can scan the cups and then they can use it. Then they can reuse the cups. So some example you can see here, like we scanned 30 cups today and so on. So here there were some technological hurdles that we had to face. So I'll come back to that in a minute. But the blockchain angle here is whenever a coffee cup QR code is scanned through the app, that transaction is recorded on the blockchain. So we can uniquely identify a cup and how many times the cup was scanned. And this information about reusing of cups aligns with the United Nations Sustainability Development Goal on waste reduction. Yeah, so we are working towards reducing the 1 billion cups that are going to the landfill. So there are two benefits of using blockchain technology. One is to report that we are reducing waste, but second is to quantify the amount of waste. So we worked on a very interesting concept here. What we tried to figure out was how many times this one cup has to be reused, maybe 20 times, 30 times, 40 times, to reach a stage when that cup becomes carbon neutral. Okay, so this is an interesting concept. So for example, when you are making a cup, right, there is a lot of energy that goes in, a lot of pollution that happens to manufacture one cup. So there is a carbon that value that is assigned. So for manufacturing this cup, maybe we generated 1 kg of carbon, right? We don't know the exact number. This is just a example. So how many times this cup could be reused to reduce the carbon consumption to 0 in comparison to the different cups, single-use cups that would have gone to landfill, right? For example, if I have this one cup, reusable cup, and it is used 40 times, and on the other side, I just use 40 different cups because I'm not reusing them. So how much is the carbon that is wasted with these 40 cups? And is that less than having this cup reused 40 times? Okay, so at one point, this will start to grow. This number, the wastage is reducing, and then the carbon already becomes 0. And from that time onwards, the cup is not only carbon neutral, but it is positive, which means it is not impacting the environment, but it is actually benefiting the environment by being this thing. So the whole carbon capture or the carbon footprint of the coffee cup was captured using blockchain. So it's a very interesting use case, something that typically people will not be thinking about when they think about blockchain, because you always read standard use cases in the world, on the internet. But this is a very unique use case. Here you can see the team who was part of the development. Okay, next project is Project 4. And Project 4 is a blockchain platform, our own blockchain that we are developing as part of my work here in the lab. And we call it the XBC blockchain. And the reason why we are creating this blockchain is because we tried to identify the technical challenges with the existing blockchains and figured out what can we do to make the next generation of blockchain. And that's where we came up with this idea of XBC blockchain. So we say that it is a lighter blockchain, simpler, greener, and secure. So those are our 4 kind of building blocks for XBC. So this is currently in progress. So we are working on this chain, but it will be much more of a enterprise blockchain solution, not for cryptocurrency or tokens, but for information capture on the blockchain for enterprises. So like you can say here, it is designed, engineered, and optimized for enterprises. Okay, next project is again in the carbon space, carbon capture, where we worked with Steve to build a real-time carbon trading on blockchain, carbon trading platform on blockchain. Basic idea here is that whenever any organization or company is involved in manufacturing, like creating a product or delivering a service, there is pollution that is happening, right? For example, while I'm giving a lecture to you, I'm using electricity for doing this, and that when the electricity was generated, there was some emission that has happened, right? So although you cannot see the actual fumes of carbon in the air while I'm presenting there, but it has happened somewhere else. So this platform helps to record carbon, how much carbon has was generated during this project. And the second was to help the help to trade it. What that means is, when you generate carbon, you have to buy carbon offsets. That means either you have to go plant trees that match your emissions. So if you're generating X amount of emissions, you may have to plant Y number of trees so that it is balanced. But a lot of time companies do not go planting trees because that is not their core business. But there are companies whose core business is to plant trees and calculate how much carbon is sequestered or collected back from the environment and gone into the tree. So these two people can then trade. So this person needs carbon offsets. This company can provide carbon offsets, and then they can trade on this platform. All right. The next project 6, is on soil carbon capture. So this is a very interesting project. And I just now explained that we already have a carbon trading platform, but a lot of things something new that is happening around the farms in the world is called as the concept of carbon farming. You know, what that means is you are actually growing crops that help you to capture more carbon from the atmosphere so that you are making the environment a better place. So soil carbon capture is a process where companies like soil testing companies go and visit farms, and they do like a site analysis of the farm, saying that they look at take a few soil samples from all across the farm, and then they will do sampling, like they use a spectroscopy meter or something, some equipment with which they put a sample in that machine, in that equipment, and it gives a reading of how much nitrogen is there, how much phosphorus, calcium, all the melons, and also calcium, and carbon, right? So by looking at that readings, the testing companies, soil testing companies, can recommend the farmers, you need to do these 5 things or 10 different things to improve the quality of your soil, so that when you grow any crop, and they also recommend that you can grow this crop, you know. So when they grow that crop, your carbon content in the soil will become higher. And how is that beneficial? It's beneficial because when you take when the carbon content in your soil increases, the value of your land grows, because you can generate carbon offsets, which you can then claim as carbon credits. So you collect carbon, and then you say, now my land has X amount of carbon that I have collected in the ground by cropping this crop. and that's good for the environment. And now I want to claim this many carbon from the department. So where does the blockchain come here? So recording this whole process is critical because we do not want to have a situation which we call as double spending, right? What does double spending mean? Double spending means if I have, say, 1 hectare farm, I go and take some samples and figure out how much carbon is there, but I can also add some other information to that, right? It could be I take multiple samples and then still add to the collection. So there is an opportunity to fraud the system. So if the information that is captured and analyzed and it is consistently and accurately recorded on a blockchain, that kind of thing cannot happen. And other than that, what we also done for this company is every time they take a soil sample from which the carbon is computed using this equipment that I mentioned, we store that carbon in a small casing, like a small box. For example, when you typically buy a gold coin or a silver coin from the jewelers, they put that coin in a small casing, right? Small transparent casing. So we use something similar to that. We put the soil inside, we cover it, seal it, and then we put a QR code on top. You can also put a RFID tag, but in this case, we put a QR code. And that small casing is permanently stored in a storage. And the reason for doing that is later down the track, if there happens to be an audit where this information is to be audited, or the department wants to verify your claims on these things, then in that case, we will have a complete record. It's not only the record on the blockchain, but same record of that on the in the physical storage as well. And another way that we link this thing is when we sample this and take one sample and put it on the blockchain, the transaction confirmation or the transaction hash we can print, and we can also put it on that small casing as well. So there is a two-way connection. It's not only the QR code that we are putting there, but when we get a confirmation from the blockchain, we can also stick it to the to this item. So in this case, we are building there are quite a few things that we are doing in this project. One is building the whole software infrastructure where all the details about the farms are added, all the information about the different sampling mechanisms that are used, that are done. So there is a software element which captures the information. There is a blockchain element, which the blockchain is here, software is here, and user is using from here, right? User is entering some information to the software, which is a standard software, and the software then talks to the blockchain underneath, and then that all information is recorded here. From this software, we also connect it to the physical storage where all these soil samples are stacked. So one challenging part that we encountered while doing this project was how to safely store these samples, because you can imagine if the farm is 1 hectare, 10 hectare, or 100 hectare farms, the samples will be a lot. It probably takes months to finish just one farm, to do all the sampling and saving all that information. So that was one challenging bit, was how to store physically. And the second challenging bit was how to represent the same digitally. For example, you can imagine there is a shelf, and then we stack all these cases one over the other. There has to be a virtual representation of that shelf in the software. So we can see that these are if there are 10 cases stacked one over the other. In the real physical space also, there has to be 10 stacks. You cannot go and change from there, because if something changes there, we cannot keep a record of that change in the virtual representation. Although we can track it still with the QR code and the transaction hash, but from a practical point of view, if you have like hundreds and thousands of these small cases, finding that will be challenging, if not impossible. So that was a very interesting experience working on them. And next, what happened was once we built this system for them, they also wanted us to work on building a new soil carbon assessment methodology. And this is interesting. See, what happens is, at the moment, what there is, say, a method on how to calculate carbon from a farm. Okay, so if the farm is, say, 10 meters, 10 meter by 10 meter. Okay, just imagine. So where should I go and take the samples from this farm? There has to be some mechanism, right? I can't just randomly take samples from anywhere. So there are methods that we need to follow when we are doing sampling of the soil. So it says first sample should be here, the next sample should be here, the third would be based up here, and all these locations actually are derived based upon a number of factors. But what is interesting is that some of these models are very basic, and I'll give you an example of what I mean. So as per one of the methodology, it says that if you grow a plant, and if it reaches so once you grow if you grow a plant and it reaches, say, 2 meters high height, then it will generate X amount of carbon. Yeah. If the plant grows from 2 meter to 4 meter, ideally in real world, the carbon that will be converted or sequestered will be much more, right? However, there is no option in that method. So even if it is 2 meter or 4 meter, it is still the same amount of carbon. So there are loopholes like that, or some weaknesses in the existing models or existing methodologies. So we came in, so we were approached by one of the industry partners to help build them a carbon assessment, a new carbon assessment methodology, which kind of prevents this from happening. Okay, I think we can take a break now. It's 1 hour since we started. I will take a 15-minute break, and then I will come and then we'll talk about the other projects that we have done. And then I think I would like to speak a little bit more about the research directions, because that was one of the questions that was keep coming up over the last few days. So let's take a short break, and then we can continue with the remaining projects. Okay, let's take a short break. Thank you.
Thank you.
Okay, let's continue with the session. I'll now talk about project 8. And project 8 is about plastic pipe recycling, or you can say plastic recycling provenance using blockchain. So plastic pipe recycling was a project that initiated as part of from the mining industry. What happens in the mining industry is after a few years, the water pipes that are used on the mining sites get decommissioned, which means they have to be removed and new pipes have to be used as per the regulation. So here to maintain a complete end-to-end or a closed loop supply chain, we had to build a blockchain solution. So what does it mean by a closed loop supply chain? So closed loop means you start with a product, right? It is manufactured for the first time. It is used in the industry for some purpose. Once it is decommissioned or removed from the use, it has to be recycled and then remanufactured to be reused. Okay, so that is called as the closed loop supply chain. So this is a loop that is closed. The loop is what? Starting a new product, using it, decommissioning it, destroying it, recycling it, and remanufacturing something. Okay, so that is the concept of recycling. So here the client wanted us to build a end-to-end traceability from the time these plastic pipes are picked from the mining site. They are loaded onto a big truck and then they are driven to a plastic recycling facility where they take these pipes and clean them, crush them, break them, and use some machines to kind of make small beads, like you can see here. They make small beads like this. So pipes become beads like this. And from these beads are either sold in bags, like 10 kg, 20 kg, 100 kg bags, or these beads are then used to remanufacture the same pipes. And these pipes, when they are manufactured, they are again sent back to the mining company, to the mining site. So this was the whole end-to-end solution that we had to build for one client. So PVC pipes being treated and dumped as waste, we pick them up. When we built the solution, we used RFID and or QR code. I mean, both options are available. QR code is easier because we can print it. So each pipe was, we put a QR code on the pipe, and so that we identify this. And for this, we built a mobile app. This is the name of the company, D&M Waste Management. Each QR code is custom designed for that particular pipe. So imagine a truck driver who drives this big truck, and goes to the site to collect the pipes. So first step that the driver has to do is to print the QR codes and stick those QR codes on individual pipes. Then use the app that we have built to take a photo of the QR code and upload that information to the app, which is then connected in the backend to the blockchain. And then the driver drives the truck. So once they have put the QR code and loaded all the pipes on the truck, the driver then has to drive the truck from the mining site to the waste recycling facility. If the client needs that these pipes need to be GPS tracked as well as they are moving, we can incorporate that as well. But in this case, that was not the requirement. So we needed evidence that pipes are picked from the site. We needed evidence that the pipes can reach the processing facility where they are processed, and either the beads are created or new pipes are created. So that whole process of picking the pipes and delivering it to the site, and then remanufacturing the pipes using these old pipes, that whole process we captured on blockchain. This was the technology stack that we use. React was used as the front-end technology, Node.js in the back-end. So here you can see interesting thing. We have a database and we have a blockchain, right? A lot of times, like even I mentioned earlier on in the earlier sessions, that if you are using a blockchain, doesn't mean that you cannot use a relational database, right? And the reason, the way we used a relational database here was, see, every information is not necessary to be recorded on the blockchain, right? Blockchain is very heavy in a sense. So the most relevant information that is required from a audit perspective or a transparency or a traceability perspective, that information can be stored on the blockchain. So we did that. All the other information does not need to be on the blockchain, right? I don't need to know the name of the driver who was driving the truck. I'm more interested in the pipes, right? So the driver's name or their personal details can be in a relational database. And another reason for that is the address may change, their phone number may change. So such information, if you put on the blockchain, it will be very difficult because we cannot change the information once stored there. So any information that needs to be changed, makes sense to keep it in a relational database. But anything that is should not be changed, that information we store on the blockchain. So in a sense, what we are doing here is any information that this software is capturing is recorded in the relational SQL database. But some of that information, which has to go to the blockchain, we send it to the blockchain. So imagine a smart contract. When we have written the smart contract, it says capture the QR code from the pipe and store it on the and save it on the blockchain. So if that has to be executed, that will execute that way. So we will, once the QR code is scanned, that information, the location, the GPS location of the phone of the photo will be transmitted to the blockchain. The file in fact, the actual photo of the file will be stored in a file management system or in a decentralized file system such as IPFS, which is a Web3 type file storage system. So where you cannot change the content of the file. And all the information that is on the blockchain is also there on the relational database. So what happens is when we are using the app for general purpose, where we do not have to prove traceability or auditability, we don't need to go and get information from the blockchain. Yeah, for general day-to-day use, information from the MySQL database can be used, and that's how we have designed the system. But if, say, for example, there is an audit and somebody comes to audit your information, right? At that time, they would need to know that the genuine, original, authentic information is there on the blockchain. So in that case, in that scenario, we will fetch the information from that blockchain and then furnish it to whoever is requesting it. But otherwise, we can rely on the SQL database because if you think about it, MySQL or in general, the relational database technology has evolved over, I don't know, 30, 35 years. It is good at what it does, right? So why not leverage the power of relational database to build a software? But our objective here is to solve a problem. I think I mentioned that in my earlier session as well, that we are not limited by technology. Our objective is to design a solution, a software that solves the problem for a client, right? So if blockchain can help, let's identify where blockchain can really add value and use blockchain for that. If there is some other technology that can add value, that can help us solve the problem, let's use it for that, right? So there is no point using a relational database and try to make it work like a blockchain when we have a blockchain that we can use for that, right? So when we architect a solution or when we build a software, a blockchain platform or a blockchain solution for a client, we look at the problem and we identify what we need to do to get the best of all the worlds, right? So I can use artificial intelligence or machine learning. I could use IoT or sensors. I could use relational database. I could use blockchain, because the end objective is we need a solution that solves the problem. And if that problem can be solved partly using blockchain, partly using a relational database, partly using AI or ML, then we just combine this. We fuse different technologies and build the solution. Okay. Let's move on to Project 9. So Project 9 was a gaming online game that was built using blockchain and NFTs. So I briefly explained to you what an NFT is in the earlier sessions. So here is a good example of how NFT is used in the gaming world. So when this company came to us, they wanted our experience and our assistance in auditing their smart contracts. So I think one of the questions during the tutorial earlier was how can we ensure, or something along the smart contract authenticity or auditability side. So this is a real world example where our task that we were given was to identify or develop a way to reduce the gas fees by optimizing the source, the smart contract code. So we did that for this gaming company. And that was the main objective. The second was to have the NFT integration so that they can buy different tanks, which is like an NFTs in this case. Project 10 is called as TrueView. And this project was developed to promote tourism by building a reward token system using blockchain. And this project started after COVID. So COVID had a major impact on the Australian tourism industry because for 2 years, as you know, there was all borders were closed. People could not travel. A lot of businesses in the tourism and hospitality sector were suffering badly. So one company came to us, they wanted to build this platform to provide reward tokens to promote tourism. So the core idea was that to create an app that facilitates the trading of digital tokens for goods and services. So if I am a user, if I am a tourist and I am visiting a tourist destination, I want to see maybe I want to see different tourist attractions there, right? So what I will do, I would go and buy a ticket to visit maybe a cave or maybe take a ride or whatever the tourist attraction is. So the idea then what we had here was, when instead of just buying cash and getting the ticket, we created this app where they could do the same thing, that is still buy the tickets, but they will use the app to buy it. And it is nothing novel or nothing new in this way. There are already many different types of coupon companies that are built there. But here the vision was a bit more bigger, larger than just selling coupons or a discounted entry tickets, right? So if you look at the next bit, the second paragraph that of this document, of this slide, it says, economists faced economic modeling challenges due to lack of concrete data about the multitude of buying and selling that goes on within a region. So what this means is the higher overarching objective was to do economic modeling of a tourism destination, right? So what are tourists doing when they are visiting a place? Do they go and buy an entry ticket for a place to see? Do they go and have food at these restaurants? They are having a coffee here, they are staying here. What is the tourist doing? So if we can get insights into tourism activity, we can, and if that information is verified and captured, in an immutable way, then we can go to the government and request for special funding to support the infrastructure required in that tourism destination. So that was the main objective behind building this system, building this software. These are some of the screens. These are some of the screens that you can see of how we have built the solution. So, as part of the solution here, every transaction is recorded on the blockchain. This ensures that the data is trustworthy, immutable, and freely available. The overall objective was to gather tourism intelligence, right? What are the tourists doing? How are they traveling? Maybe they visit this city first. From this city, they go to this city, and then here, and then here. What is the standard travel path, and how long do they stay at different paths? What kind of services they are looking for in these destinations? So that all was the idea behind building this platform. And another thing that we integrated in this solution was every time you buy a token or fill up your wallet with this, you are able to so you are given additional tokens. So if you, for example, you buy 100 tokens, we will give you 110 tokens. So there is always some buffer there. So if you typically just buy one ticket, you spend the money, you don't have any extra benefit. But with this, you get some extra tokens. And as you spend more and more, you can collect these more tokens. But this was just a incentive or like a hook for tourists to start using it, so that we can start collecting their travel or tourism travel pattern when they're visiting different locations. So here also, if you see, the technology stack is the same. We use React frontend, Node.js backend, MySQL, MySQL database, and Polygon chain, and it was all hosted or is hosted on AWS cloud. Okay. All right. The next project is in the health sector, health information. And this is for, again, a client-based, client-funded project, where the objective was to provide data ownership to the owners of the data. So I'll give you the background of this project and how blockchain was then introduced and what value did blockchain add in this case. So the company that we work with here is a market research agency. They do market research. So pharmaceutical companies, when they want to develop a new drug or discover a new drug, one of the steps that they have to do is to do market research. So they may say that I would like to interview some patients who are suffering from this kind of a condition, and I also want to interview some doctors or specialists in that space. So this company then takes this information from the client, from the pharmaceutical company, and then goes and interviews patients and interviews doctors and collects all this information and then sends it to a pharma company. But what happens is, on many occasions, maybe another pharma company comes to them and asks to do a similar study, similar market research. So what they wanted to do was to replicate this process so that the data could be, or the interview transcripts could be reused. But what they wanted to do was they wanted to compensate the patients and the doctors for their effort every time their data is or their interview was reused. So what they came up with the idea was the market research that they have done so whenever a patient replies to a market research, that data, that information is owned by the patient. Similarly, when the doctor interviews, that information is owned by the doctor. So they are the custodians of their own data. So we built an app to provide the patients and the doctors the control over their information, right? So if another pharma company comes and they want to access these records, which are owned by the patient, the app will send a notification to the patient saying that company XYZ wants to have access to your interview that you made earlier for this and this research, right? And they would then say, then the patient or the doctor would have the option to either accept the request, and if they accept, their data will be disclosed, and if they deny, then the data cannot be used. So the ownership of the data belongs to the patient and the doctor, and whenever the information is used, the information has to be requested, and the information has to be then disclosed for use. We also went to the extent of deciding, the pharma company telling how they want to use this information for, what was the purpose, what was the research that they want to do. And if that research aligned with the ethics of the doctors or the patients, then they would say, we are happy for you to access our data. If not, then they cannot. And this whole thing was then built on using blockchain technology, because we wanted to keep record of all this information exchange, this information, the whole traceability of this information, and that nobody is accessing the information without the right permissions. So these are some of the screenshots from the solution that we have built. This is the back end. Here we build the mobile app as well as the web app. Okay, now coming to the last project. This project is for a company called as Envision. And Envision is a Perth-based startup, and they are in a space. What they're doing is they're building a marketplace for photographers or artists, in a sense, who want to sell their artwork, like photos or videos. So basically stock footage. Typically, if you look for free images online, right, you go to Getty Images, Shutterstock, or companies like this, where they have a small collection of free images, which you can use royalty free. But for the others, then you have to pay. In these companies, the royalty that the artists receive is very small, very small. So a lot of the money from the sale actually goes to these big companies. So Envision came to us, and then they say that they want to build a decentralized marketplace where artists, photographers can upload their photos and videos for sale, and buyers can come and buy these photos and videos from them. They wanted to implement NFTs, or non-fungible tokens, to identify or to uniquely identify or assign a license to each of the artwork. So if there is a photo, there is an NFT for that photo. If there is a video, there is an NFT for that video. And then they had their own team of developers who built the platform, the content management side of it. And we came and we provided them the we provided them with the blockchain and the NFT expertise. So we are still working on this project. It is coming to a close soon. But this was a very interesting experience for us, because again, a very different sector, art and video and photography, compared to health or supply chain or gaming and stuff. And we also had to invent or come up with a new staking mechanism. I don't think I've covered staking too much in this course, but in simple, what staking means, a way of locking your cryptocurrency or your tokens in return for getting additional returns. So it could be that a company issues tokens to raise capital. Once the tokens are issued, these tokens have a value. And one thing that many companies do is to kind of lock these tokens so that the demand is reduced. So the supply is reduced and the demand is high, and the value of the tokens can go up. So we help build a new form of a staking mechanism here, wherein we said that if you stake or if you lock, say, 2,000 coins, we will offer you additional services on this platform, which these services cannot be purchased for a fee. They can only be accessed if you are staking your coins. So that way we can reduce the supply in a hope that the demand for the tokens increases. So what was an example of a staking mechanism? So we said that if you stake 2,000 coins, we will give you additional analytics, right? What is an example of analytics? So we can say we will give you the search history of what people are searching on the platform. And this is important for the content creators, because if the content creators know that users are looking for photos of sunset or photos at the beach or videos of the beach, then they can go and create that content. So that search history of what users are looking for is an example of a feature that we can offer to the users in return for staking their coins on this. So these were the projects that either are completed and delivered or they are in progress. But other than that, there are a number of other projects that are in the pipeline that we are working on. And like I said, some of you are quite interested in working on the actual technical side of blockchain. This could be an opportunity for you to approach us if you are interested in working on any of these upcoming projects. What else? We also do some industry reports based upon the research that we do. So like here, there is a report that we did last year, which was on traceability of rare earth metals. We also did a report on certification and recruitment and so on. So other than all this, there are a couple more projects that I want to show you. They are not in the slide deck. So let me just stop sharing this and open up the actual website to show the work that we are doing there. So give me 1 minute. Okay, are you able to see the screen?
Yes, sir, it's visible. Okay.
All right. So this is another project that we have just started to work on for another client. AYR International is the name of this company. And AYR stands for Action Yields Results. So that's the full form for AYR. Here we are doing tokenization of real estate. So companies that want to build apartment or a house or a large hotel or some projects like that, we can help raise the funding or the capital that is required to execute these projects by getting or selling NFTs through for these projects, and then those who buy the NFTs, they kind of own or part of the share of that particular project. So it is, instead of raising money from the bank to fund the development or the construction, we raise money from the users or consumers. So there are three things in this project. One is smarter communities, which is the actual housing, that is being built. These houses or apartments are then also integrated with green data centers. So green data centers are there because they can provide access to network infrastructure very close in these newer developments. And the third part of this is the green energy, so solar energy. So the idea is you build a house or an apartment or society. There is solar panels on the society on the roof, and that solar panels provide energy to the community and also provide energy to run the data center. So this combination of three things is what is the core of this project. And here we are using, again, blockchain tokens and NFTs to get that community engagement and the involvement. You can check this out later. Another project that I'm involved in is this project called Nicho NFT. And Nicho NFT is a decentralized marketplace for trade NFTs, to create NFTs and to trade NFTs. So we have recently launched it. You can see we only have 2,700 users, but there are a good collection of NFTs that you can buy or you can sell. The interesting bit with this project is that we give you the opportunity or the option to create NFTs, mint NFTs, and sell those NFTs, the whole thing on this platform. In the future, we are also going to introduce new games that will be part of this Nicho ecosystem, or we call it the Nicho planet. And it is currently using the Binance Smart Chain, but we will be adding other chains to this network in very shortly. And yeah, so you can also give this a try if you want to get a feel of how this platform works. And it's part of the metaverse as well. So Nicho Planet is the Nicho metaverse that we are building. Okay, so I think that is all I had to cover in terms of the different projects that I'm involved in, and to give you an idea of the potential applications of blockchain in different industries, and share my real-world experience on building commercial blockchain solutions. So we have another 10 minutes or so. So if you have any questions, then we can take up the questions now. Or if something was not clear during the presentation, you can ask me questions for that too. Thank you very much. I thought giving this actual real projects will probably broaden your vision or thinking of what is really possible using blockchain, rather than just talking about theory. So giving this practical side, I think my vision was that you will really see the power of blockchain. It's not just on paper or thoughts, but it is actually a real solution. Always need or make an app for individual block. App is required, like a mobile app or a web app is required to interact with the software, right? Interact with the solution. So anything, even if it's a blockchain or it is not a blockchain, you have to use an app to kind of communicate. So every time any function is executed on the mobile app, in the backend, the smart contracts connects with the blockchain and stores the information on the block. So yeah, to answer that, yeah, we need an app or a mobile, either a mobile app or a web app. Any other questions from anyone? Okay, so if there are no further questions, we can conclude the session. I'll upload the slides to the Google Drive now, so you can have a copy of the slides. Okay, so Shivashakti, to answer your question, data entry is always a challenge. So we have to figure out a way of how data, of how we are going to make systems available to record the data. So I give you an example in the project when we built the high track system, is where we had photographic evidence, or we can also have CCTV footage as the evidence for data collection, for data capture, and then putting it on. It is difficult, that is right, but we can always come up with some practical solution to capture the required data. So even using the drones, like I said, if the drone goes over the field and captures any information, I think that is also a way to data capture. Office attendance project. In fact, day before yesterday, in the session, I gave you an example of the construction industry where the attendance system was implemented using smart contracts. So yeah, that is very much possible to build a system around that. Okay, Malay. So can I conclude the session, and then you have to take some session as well, right?
Yes, sir. If I hope one more questions. No questions are there. So you can conclude the session. So after 5 minutes, I'll start the session around 11:30.
Yeah. Okay. All right.
Yeah.
All right. Thank you very much.
Yeah. Thank you, sir.
Yeah.
Good morning to all. Am I audible? It's recording. Can I share the screen? Yeah. Good morning to all. Sorry for the inconvenience due to network failure. So welcome you back for this second depot, I can say third day program. Sorry, fourth day program of blockchain. So today we'll talk about blockchain for deep learning. And yesterday we have discussed about this blockchain for this deep learning, and we have discussed about this following informations. That is introduction, learning, and what is learning, neural network, machine learning, deep learning, as well as blockchain, and how blockchain can be effectively used in case of deep learning for different purposes or to improve the performances. As we have discussed that integration of a blockchain in deep learning has many benefits, and we have noted down a few: that automated and trusted decision making, efficient data market management, data security, better model building for prediction purposes, model sharing, and enhancement of robustness of the deep learning based systems. If we look into some of these other benefits, that is elevated data security. If we look into that elevated data security, in this case, the data can be represented as an oil to the deep learning engines, and blockchain ensures of the shared data. And if we look into automations, basically in case of smartnesses in devices and automation in reality due to the integration of the blockchain as well as the deep learning. And cumulative judgment also is one of the important advantage of this blockchain when incorporated in deep learning. One of the best example is the swarm robots, and how the swarm robots can make a collective decision for a particular kind of applications. So as we know, the swarm robots are generally used for many purposes, to monitor the environment, to establish communication in case of a network. So enhanced robustness. So whenever the blockchain is used in with the deep learning, it will enhance the robustness due to the collective data collections, because deep learning is based on a centralized server, whereas the blockchain is used in case of a decentralized servers. So already we have discussed these things, that blockchain with ML, that is the advantages: data authenticity assurance, data usage management, audit trials, as well as introducing new values to the business processes. So what we'll discuss today, so we'll discuss about blockchain based deep learning framework and how we have partitioned our partitioned this presentation. We will discuss about this blockchain-based deep learning frameworks based on the parameters, and here we have discussed about 7 parameters. Based on the strength as well as weaknesses, we can compare both, as well as we look into some research challenges. So if we look into the taxonomy of blockchain-based DL, this taxonomy of blockchain-based DL has key benefits of a blockchain and DL. Already we have discussed these parameters. So now these parameters, whatever we look into, that blockchain type based on blockchain platforms. So these parameters are public, private, as well as consortium. So these things already we have discussed. Already Professor Vidyasagar has already discussed about what is public blockchain as well as private blockchain as well as consortium blockchains. And these blockchains can be integrated with this deep learning. So in public blockchain platform leveraged by the existing blockchain assisted deep learning framework. So when we are use this deep learning framework in this public blockchain, this will allow unrestricted access to the distributed ledger by user or machine learning devices. So public blockchain platform maintain transactions because of decentralized data storage as well as processing. And this is secure against any type of attacks. Next is the private blockchain. This private blockchain platforms leveraged by the blockchain assisted DL framework and are controlled by, managed by, or managed by a single entity. As these entities are validators and nodes and are known to be the central authority, hence the private network requires a relatively lesser complex mathematical calculations. As they require lesser calculations, so these private blockchains are very faster in nature. So this consortium blockchain platforms leveraged by the blockchain-assisted deep learning networks and characterized by both private as well as public blockchains. So this can take the data from multiple heterogeneous groups and can have an authorization role. As already Professor Vidyasagar has discussed these things with respect to these blockchains. So we are talking about these blockchains can be used, that of public, private, as well as consortium in deep learning cases. So in consortium blockchain, the transaction validation rate of consortium platform is faster than the public blockchain platforms. Next, already we have discussed some of the parameters related to the deep learning models. So this blockchain can be used certain deep learning models. In previous class, we have discussed about different deep learning models such as convolutional neural network, recurrent neural network, DRL, that is reinforcement learning, that is deep reinforcement learning, geometric DL. So just quickly, I want to say, if we look into this convolutional neural network, which is popularly known as ConvNet, and it is used for classifications, and blockchain is used in CNN for classifying the different kind of images, and where the classification is required. It can be required in case of medical data. It can also be required when roadside assistances, that is GPS services, etc., etc. So as we are using CNN or blockchain in CNN, it has an advantage that less time processing, and it doesn't have any kind of memory. If we will compare this CNN with respect to the recurrent neural network, this recurrent neural network, there is a feedback from this output to the hidden layers, or there is a self-feedback is also present in case of this recurrent neural network. So these recurrent neural networks are incorporated with memory to take any information from the prior inputs and influence the current input as well as the output. So this recurrent neural network gives output based on the previous input as well as the context. So this uses a sequential data. What is sequential data? That is the time series data have been used by this recurrent neural network. The parameters across each layer shares the parameters. So if we look into this CNN network as well as the recurrent neural network, the recurrent neural network share the same weight parameter within each network layer. And this recurrent neural network for blockchain-based solutions includes for different applications. Few of the applications of this recurrent neural network with blockchain mainly used for voice speech recognition system, speech to text recognition system, natural language processing, voice search algorithm, etc. This recurrent neural network is not very efficient because it has a vanishing gradient problem. So in order to overcome that difficulty, people have used the LSTM or the blockchain has been used in case of LSTM, or that is gated recurrent neural or gated recurrent units also used in place of this recurrent neural network. So this LSTM as well as gated recurrent units have been used or uses the blockchain for identifying the different digits, classification of the different digits, etc. in case of time series data. So this, if we will compare this gated recurrent unit as well as the LSTMs, the gated recurrent unit uses two blocks, or we can say that the gated recurrent unit has reset gate as well as this target or reset gate as well as update gate. Whereas in case of LSTMs, we have the three gate that is known as the input gate, forget gate as well as the output gate. The next is called deep reinforcement learning. Already we have discussed about this deep reinforcement learning, and this reinforcement learning uses an agent as well as the environment, and from this environment there is a feedback to the agent, and based on the feedback the agent had to take an action so that the reward is get maximized. Now blockchain is using this DRL, that is deep reinforcement learning, in case of roadside assistance, in case of accidents, or in case of logistics. So agents are basically implicitly validated or penalized depending upon their behavior. Next is called the geometric DL. This geometric DL is also used in case of a blockchain. Basically, this is CNN, recurrent neural network, deep reinforcement learning. This type of neural networks are based on the Euclidean distance. What is the Euclidean data? If we'll understand this Euclidean data, then you can understand what is called Euclidean distance. Basically, the images, the speech, the ECG signal or EEG signal, any kind of signals are nothing but Euclidean data. But there are certain data which are not Euclidean. So some of the best examples of non-Euclidean data are graphs. So basically, this geometric DL is popularly using this non-Euclidean data. So the graphs, so the data modeling can be done by less effort as well as resources while using graph-based data. So the graphs are the input to the geometric DL models and extract more granular details from the data. So basically, if we look into our real data, these real data are basically geometric data. If we take some examples of this geometric data, then we can give an example of molecules, the trees, the networks, or the manifolds. These are non-Euclidean data. If we'll talk about this Euclidean data, that is nothing but the images, this audio, this ECG signal, EEG signals, etc. are called the Euclidean data. So these are some of the models or the few models which popularly uses the blockchain for different type of applications. Next, we'll talk about the parameters that is called deep learning specific conscious protocols. What is this deep learning specific conscious protocols represent? This minimizes the convergence time of the conscious or agreement process in validating the transaction and assisting the agents in a multi-agent based system to reach an agreement while using a minimal resources. So the traditional conscious algorithms such as proof of work are slow as well as less energy efficient. So what is this proof of work? This proof of work describes the system that requires a non-insignificant but feasible amount of effort to discourage frivolous or malicious uses of the computing power, such as sending spam emails, launching denial or service of attacks. So these DL-specific conscious algorithms basically include block ML, commit conscious mechanism, Waka coin, proof of learning. So what is block coin? Block ML, that is block ML is a protocol that minimizes the compute intensive operations in the neural network's training phase using a supervised approach. So this block ML forces the miners to solve a task using the same input data type and generates a competitive model. The suppliers and the training data are vital components in block ML architecture. Next is the commit conscious mechanism. This conscious algorithm or that commit conscious algorithm updates the global model using a federated or joint learning based approaches. So this commit conscious mechanism updates the model locality and then adds into the blockchain. So the blockchain part of this federated learning is divided into two parts. The first part of the blockchain stores the randomly initialized model at the time of system initialization. And the second part of the blockchain is responsible to store the model updates generated by partitioning the nodes in the federal learning-based systems. So these nodes essentially obtain the model present in the blockchain and undergo the training locally. So next is the Weka coin. So what is this Weka coin? This is nothing but a cryptocurrency, and it provides a decentralized database of machine learning models which are publicly accessible. So the block of Weka coins holds three items such as transactions, the hash of the previous block, and the information about the machine learning context used to verify block in the previous iterations. Next is proof of learning. The proof of learning algorithm practices a non-convex optimization approach of potentially large size neural networks and exhibit NP hardness characteristic because of the computational complexity in solving the asymmetric challenges. In this system, a secure mapping layer is introduced for this tamper prevention. So this is all about the parameters that is DL specific conscious protocols. Next, we'll look into the application areas. There are many application areas of this blockchain with deep learning, and main important application area is the healthcare, Internet of Vehicles or IoV, traffic management, safety. So if we look into the first application, that is healthcare. So basically in healthcare, the patient data is very, very vital or very important. So healthcare data consists of different informations like electronic health records, such as the signals, scans, or some kind of reports, etc., etc. So if we look into the electronic health records, basically consist of the signals or these scans or reports. These are very huge in dimensions, huge in size. And this will be managed by a central server. But due to blockchain, it can be decentralized and can be used in case of or used by the help of deep learning for different purpose or different kind of applications like classification, disease detections, as well as to monitor the health of a patient, etc. Take one example of COVID-19. If we look into this COVID-19, basically what are the information we are looking, whether this COVID-19, whether I am COVID positive or not, whether I am belong to which place, I am belong to or what is the age of mine, whether I have taken a vaccine or I have not taken the vaccines, whether I have quarantined myself after COVID positive or not COVID positive. So it is dealing with a lot of information about a lot of informations. So this COVID-19 as well as can be effectively analyzed, effectively to be taken care by the help of a blockchain as well as the deep learning. So if we look into some case of communicable as well as non-communicable diseases like cancers, whether a person is having cancer, which type of cancer, what is the stage of the cancers, this can be effectively diagnosed as well as diagnosed for improving the quality of healthcare services as well as the clinical trials. Why there is a clinical trials? Because whenever we are talking about the health images, or that is called different scans, signals, or these images, this has been used for the different purposes, that is research purposes, etc. So the healthcare data, as I have discussed, consists of the records related to different diseases, disease symptoms, medical profile to the patient that assist deep learning in predicting medical conditions of the future patient. So the high security and precision of such healthcare data is utmost requirement of the industry and directly affects the human life. So in order to avoid this kind of problem, storing such data in a centralized system makes them to different kind of attack. So we have to store the data of this medical data in different servers, or we have to make it to decentralized. So hence blockchain technology in this case can play a vital role in preserving all the data as it is inherently decentralized and provides a solution to a data security threats. So blockchain assures the data set from the planned or accidental loss. Next is called this Internet of Vehicles. Before coming to this Internet of Vehicles, I just want to show one text here. So here there is I have taken this figure from this paper of this Poddar, Itala, and the title of this paper is Securing AI-based Healthcare System Using Blockchain Technology, a State-of-the-Art Systematic Literature Review and Future Research, which was published in the year of 2022. So if we look into this medical data, So this medical data is consist of many things. One is called the text. If we look into the text, that is consist of clinical reports, lab reports, handwritten notes, other documents, etc., which is very, very numerous in nature. Now, if we look into the image is also, there are many kind of images, many modalities are present. The X-ray images, CT scan images, MRI images, ultrasound images taken by different type of cameras or videos in case of, if you have some video images. If you look into these audios are of different types, that is coughing sound, breathing sound, heartbeat sounds, as well as some other kind of sounds. So this input which is given to this medical data is numerous. And if we look into the information or the data for a particular patient, then and it will make it to centric, or that means server centric, or we can make it to centralized, then it will prone to error. So we have to make it to decentralized. So the common challenges that we are facing is that it is a very huge amount of data. There is a diversity in data. So that means different things are present. Text data is present, image data is present, audio data is present. So processing of all the data, the different forms of data is very difficult by the help of a human being. So machine learning plays a very vital role in this case, as well as blockchain is also plays a very vital role in this case, because the security is the essential part in this medical data. So if we look into this data, this will be a data acquisition. Already we have discussed last class, text cleaning, pre-processing, feature engineering, as well as modeling, evaluations, deployment, as well as manufacturing, as well as model update. So now when we are talking about this data, we are extracting certain features from whether it is your text data or image data or audio data. So we are extracting the features, and these features are given to the deep neural network model, and this deep neural network model can able to perform the classifications. So that means we can able to do the classification based on the symptoms, based on the certain kind of features present in the different data. So this has a common challenges. We'll come to this common challenges. Already we have discussed many times that it is accuracy as well as structural format of the data is a challenge, because if you look into the text data, different doctors are writing in different maybe different text, different handwritings. Lab reports are not uniform. They are having different formats, clinical reports or other documents, etc., etc. So there are different formats are present. So there are huge challenges are present in case of medical data. So this deep learning plays a very vital role for analyzing this information from this data, as well as it requires the security. So we'll talk these things again after discussing these parameters. So these application areas are healthcare. Already we have discussed how this blockchain can able to help the healthcare data for security or security. So Internet of Vehicles. So there is an increase in popularity due to the Internet of Things as an instrumentation technology for the vehicles has a rapidly increasing network capabilities of existing devices. So these vehicles in modern transport systems are usually equipped with different type of devices, sensors, intelligent softwares to connect to other vehicles, roadside units, as well as to transmit the information or the data to other devices. So by introducing this blockchain into the Internet of Vehicle network, the data can be securely shared among the different entities. If we come to this vehicle-to-vehicle communications, this is a mode of intelligent transportation system and enables vehicle to share data about the vehicle position, the speed, the congestion route, the heading angle, as well as road state and other vehicles conditions. So this we can able to help you to find an efficient route to reach at the destinations. Or it can say that it can find an optimal route to reach at the destinations. So this Internet of Vehicles, vehicle to device communications or vehicle to some instrument communication enables the vehicle to share the captured data at the roadside units, such as maybe RFID readers or cameras or lane makers and street lights for improving the public safety, efficiency, as well as convenience. Next is the traffic management. See, the road congestion is one of the biggest issues in urban areas and can result large financial as well as ecological losses due to increased carbon dioxide emissions. Already, Professor Vidyasagar has discussed about more in detail. So, one of the most widely used approaches of forecasting this traffic intensity is the real-time data in crowdsourcing. So, however, these crowdsourcing modules are impractical due to centralized based data storage and human safety concerns. Next is called the safety. So, this blockchain technology is well known and practicable in various fields due to security features, and it provides in terms of the immutability of the data. Next is the services. If we'll come to these services, there are privacy preservation, anomaly detection, traffic management, as well as electronic health records. So this electronic health record, will talk much about this because we will discuss about these applications more in detail. So this electronic health records refer to the digital version of the patient-related data as lab results, history, allergies, as well as prescribed medicines, etc. So there is a requirement of data integrity, data protection, as well as secrecy in case of these electronic health records. So electronic health record forecasting using deep learning techniques assisted in predicting health solutions in case of a particular region for facilitating the healthcare services in that region. So if we look into this electronic health records, basically we can see the different data types. Already I have discussed these things. So we are talking about different data types. One is called the image data. So in case of the image data, we are talking about X-ray, CT scans, MRI, ultrasound images, videos, etc. Text data, already we have discussed, that is clinical reports, lab reports, handwritten notes, other documents, etc. So audios, coughing, breathing, heart sounds, as well as other sounds. So when we are talking about this different type of data, these different modalities, that is X-ray, CT, MRI, ultrasound, we have to register. That means we have to perform a work of registration such that the information present at the different modalities can be combined to give a better representation to identify the disease or to identify the stage of the diseases. So that analysis by a human being is a very, very tough task. So it requires automatic feature extraction by the deep learning. So whenever we are talking about this image data, maybe a same person or the same patient is visiting to different hospitals. So the data are distributed in different hospitals or different servers. So in that case, blockchain plays a very vital role. So text data, if you look into the text data, the clinical reports, the reports given by the doctors, the lab reports, the handwriting notes, etc., etc., there are numerous in nature. They have the most variability is present in this case. So by analyzing all the reports is also a tedious task by the help of a human being. So automatic analysis is one of the requirement or today's requirement. And whenever we are talking about this text data, this data is also distributed. So blockchain plays a very vital role here. So audios, similarly audios, we can talking about coughing, breathing, heart sounds, etc. So this analysis by human being for all the time is also difficult. And also this classifications also leads to sometimes that is called experience of the doctors or experience of the health personnel. So here these are slides. Already I have shown these slides. Sorry. So in this case, that is the input, processing, as well as tasks, application, as well as common challenges are present. Already I have discussed about these inputs as well as the processing, which requires this deep learning as well as blockchains. And what are the tasks we have to perform in all the cases? If you look into the text, the task we have to perform, we have to extract some useful information from the text. We have to classify the information, opinion mining. And the task which we will perform in case of X-ray or CT scan or MRI images, we have to find what is the tumor or what kind of abnormality is present. We can perform this classification, localization of the object analysis, etc. From these audio sounds or audio signals, we can able to classify the condition of the health for a particular persons or the subject. So these are the tasks that we are using, and these images have been used for different applications. Already it is mentioned here to analyze. So if you look into the text data, it can help to analyze the vast clinical data, identify critical patients, classify the disease, disorders, etc. If you look into the images, this can be used for many departments like radiology, oncology, cardiologist, dermatologist, fundoscopy, lab test automation, patient monitoring. And if this look into this audio data, this is automatic diagnosis of respiratory as well as pulmonary disease, disease of cardiac disease, measuring the pain and the neonates and detecting depressions, etc. If we look into the challenge that we are facing in case of this EHR, that is electronic health records, for efficient analysis, the common challenge that is we are facing in case of that is called availability, accuracy, structural as well as format. If you look into this text data, they are having different formats. Privacy violation as well as security breaches. Biased models, that means some of the models can able to extract a certain kind of disease more effectively. Or we will take the case of cancer detection. In case of cancer detection, certain models can able to detect the cancer more effectively. So that means this model is biased for cancer detections. If this model I will use for segmentation, it cannot able to do the segmentations. So that is a lack of trust due to this deep learning networks. That is a very that means not very trustworthy in case of models. Next is secure resource sharing and privacy preserved knowledge sharing within a research as well as the clinical experts. So these are the few of the challenges. Again, we will discuss about these challenges and how we can able to overcome in case of medical health records, that we will discuss later on. Next is called, already I have discussed about the data types and deployment goals. Now we'll talk about this deployment goal parameters. So this basically uses data verification, attestation of results, provenance, traceability of ownership, uses, and guarantee the fairness, and can be achieved in integrating blockchain as well as deep learning. So the main goal of this is called trusted AI models, AI decision sharing. What is trusted AI models? Basically, this blockchain assists establishing data provenance of the deep learning models used by various industries for data classification as well as predictions. So the predicted result by the trusted AI model are highly reliable as well as correct. So AI decision sharing, blockchain technology assists in securely sharing the data between the untrusted participants, and the AI decision sharing parameter describes the prediction made by the AI based models and time series data to secure sharing the prediction among the potentially untrusted participants. Next is the blockchain based DL framework. So under this category, we'll talk about the data analysis, provenance of data AI models, model prediction, disease classification, crowd sensing, crowdsourcing, as well as utility-based blockchain security. So if we look into this data analysis, so basically this data analysis is a patient-centric data management. So if we look into a patient-centric data management which is basically resource-friendly of a deep learning models and have been essential elements, particularly in case of pharmacogenomics research. So basically this pharmacogenomic research requires a decentralized system that provides pharmacogenomic data. And this can be easily analyzed by the deep neural network. So basically, we have to develop a model to predict these ovarian cancers. So this blockchain platform is used for sharing the healthcare data, patient records, as well as ovarian cancer prediction by the ovarian cancer data. So here in data analysis, we are using this data, which is pharmacogenomic research data. So next is provenance of data AI models. An AI model can lead to erroneous or misleading result, particularly when the source of the employed DL model is not unknown. Because already we have discussed in the last session that these deep learning models are depending upon the data because they are very data hungry, and these deep learning models can be treated as a black box. That means one model can able to work fine for one kind of data, may not be work fine for the other kind of data. So this model predictions. Next, what is this model prediction? This model prediction in healthcare requires a cross-institutional health data. Whenever we are designing a deep learning model, we have to look into the data that is available in the different institutions or hospitals, and this information is or we are performing some registration to have a better model. So the data side or it's visual now. Yeah. Sorry for the inconvenience. The network was disconnected. Yeah. So we are talking about the model prediction. So in model, or as we have discussed in model predictions, we are looking into this healthcare data, and we are looking for this healthcare data from the various institutions or various institutions. So, and this information can be registered to perform a particular kind of task. So when we are taking the data from the different institutions, we have to look into the security of the data, or security of the data from is one of the major challenges from taking the data from the different institutions. So next is coming to the data filtrations. So basically, already as we have discussed that this deep learning models is accurately predict the causes as well as the source of the disease and ensure the high quality of data. Because these deep learning models am I audible? Yeah. So as we have discussed, these deep learning models are very data hungry, and this requires a high quality of data. That means a huge amount of high quality data is required, and this data filtration plays a very vital role for filtering out the data. So the DL models accurately predict the causes as well as the sources of the disease and ensure the high quality of data. So here, Jahang et al. In 2018 developed a deep learning technique in blockchain, or that is known as the blockchain-based deep learning technology, for classifying the healthcare data into high quality as well as low quality classes and aligning such data with a certified consumers. So basically he has divided into high quality data as well as low quality data by using blockchain in deep learning technology. So when he is using this technology, he is taking the data from the different organizations, and the high quality and low quality data are get separated. Why this separation is very, very important? Whenever we are talking about a wearable devices, nowadays these wearable devices are very, very popular to get the health information about a person or a patient. See, these wearable devices are always connected with the patient, and it is continuously streaming the healthcare information to the servers. So whenever it is continuously streaming the healthcare information to the servers, so here we need not, or the doctor is not interested that about the normal data or the normal information that is present in case of a wearable device or that is coming from the wearable. So whenever this there is a variation in this data or the information from this wearable device, that is of the interest. So the filtration is very, very important in case of this blockchain based deep learning technology. So I hope it is clear to you why this data filtration is very important in case of healthcare systems, to separate the high quality data from the low quality data, as well as the data which is essential for identifying the disease. That is important, that data to be shared. So if I will share that data, basically I can consume less energy, and I can effectively do the analysis with a lesser time. That means latency will be very, very low, and we can get the result quickly. So this next is called the disease classifications. What is this disease classification? Already we have discussed that we have developed, or the people have developed different type of deep learning models for classifying the diseases. Already I told that these deep learning models are very, very data hungry, as well as they are look like a black box. That means one deep learning model work from one set of data may not be work on another set of data. So this disease classification is performed by these deep learning models to tell about the different informations, such as classifications. If here I have given an example of a classification of a particular disease, take the case of cancers. So now this deep learning model, what it will give, whether the person is having a cancer or not having a cancer. If he has having a cancer, then what is the type of cancer? If the cancer is there, then in which stage he is. If it is known that it is the stage of this and the type of the cancer is this, then can we suggest that what type of medications can be taken? So now whenever we are talking about the medications, we are looking into some prior information about these cancers. We are looking into the prior information about this type of cancers, etc., such that we can suggest, or this automatic model can suggest some of the medications, and which requires the information from the distributed servers. So already people have worked on that start denoising autoencoders to extract the features and detect anomalies that is present in the heartbeat, as well as different classification systems. So already yesterday we have discussed about autoencoders, which basically works as a compressing algorithm to compress the data. That means which are basically the required for the doctor for analyzing, that can be analyzed. So am I audible to all of you? Yeah, fine. So this stack autoencoder is used in case of ECG data for detecting the anomalies present in the heartbeat. What is the anomalies present in the heartbeat? So basically, our ECG signal is consist of P, Q, R, S as well as T waveform. If there is a P waveform is missing, or this RR interval is not uniform, then we have some anomalies, or we can say, or some others that is known as the arrhythmia, or that is known as the arrhythmias. So this arrhythmia can be efficiently detected by the stacked denoising autoencoders, which basically controls the false positive and stored in time stamped ledgers. So next is we can talk about the combined cooperative positioning. Basically, this global positioning satellite are popularly used for tracking as well as tracing of vehicles. So if we look into the issues that is associated with the global positioning satellite, there are errors in the range estimation. There may be sometimes wrong installation is present, sometimes a low battery of the GPS enabled devices, and sensing is a tradition. Am I audible? Yeah, crowd sensing is a traditional vehicle-to-vehicle communication network that privacy of participating in the vehicles and can be affected by a centralized based data storage processing. So the vehicles basically exchange the data in a trustworthy manner to other vehicles. So in this case, a deep reinforcement learning algorithm is used with this block mining or blockchain network to assist or to make a communication effectively as well as efficiently to vehicle as well as a vehicle to the other roadside units, etc. So this is very important to know what is the crowd condition. You can find one effective route for a particular destinations, etc. So Wang et al. In 2020 proposed a blockchain-based network to reduce the latency in case of vehicle-to-vehicle communication in crowd sensing. Next, we'll talk about your crowdsourcing. What is crowdsourcing? Gupta et al. In 2020 developed a blockchain network to identify and report on unwanted situations. And this smart contract plays a very vital role in that case to enable the vehicle to register and leave the network freely at any time. So proof of authority is conscious is used, DApp interface to report the event to the blockchain. Utility-based blockchain security. This utility-based blockchain security uses this deep learning concept. So this deep learning model can assist in safeguarding the blockchain from the several types of attacks. So decentralized technology is used, that is double spending problem that represent a flaw in existing cryptocurrency system and can occur, and it can enable to user spend the same token in 2 times. Rosenfeld model developed by Rosenfeld in 2000, Rosenfeld model was used. The number of verification required to keep the attractors effectiveness in double spending below 10%, 1% or 0.1% is 246 respectively. Next, we'll talk about this comparison of existing frameworks. So here we'll discuss about some of these frameworks which are using this blockchain along with this deep learning for ovarian cancer detections, electronic health record predictions, arrhythmia classifications, communication security, traffic jam prediction, traffic flow prediction, incident prediction, as well as GPS correction. So these things we'll discuss in next session. So next we'll talk about the research challenges. Here we'll talk about the few of the research challenges, that is platform scalability, data valid as well as sharing, structural enhancement as well as storage, platform throughput and latency, DL-based conscious protocols and regulation cryptocurrency, and platform interoperability, secure economic models. So this is the thing that I have to discuss today. Thank you. Any questions from your side? Please write the questions in the chat box so that we can discuss here, or we can discuss in the afternoon session also. Any questions? Thank you, Dr. Smita Bhisane. So still some couple of minutes is present. We can have a discussion.
Good afternoon, sir.
Yeah, good afternoon.
Sir, from these models, if I have less number of data, training data,
Yes.
am I audible, sir?
Yes, yes, you are audible. Please go ahead.
Sir, for less number of data, sir, which model I can use?
Yeah. Means you are talking about the deep learning models.
Sir, deep learning models, sir.
So if you have less number of data, you can go for this CNN.
Okay, sir.
But this has a problem. The problem that you will face, it will sometimes make overfitting, because these deep learning techniques are very, very data hungry, and you have to train the model effectively. And for that reason, people are generally used nowadays generative adversarial network to generate some more data, because which basically works on the principle of a generator as well as a discriminator, and the generator will generate some few more data, which basically tries to fools the discriminator, and in that case you can able to use sufficiently more number of data. So one of these use we can use, that is generative adversarial network, to generate more number of data. And another way you can use, whenever this data is very, very less, you can create more number of data by the process of augmentation, or by augmentation in the sense of either you can rotate it, flip it, or you can add some noise into that, so that you can make the training of this model more effective for performing certain kind of task. So this is the problem that we are facing in case of medical data, because the medical data are very less in number, or that means a very less, we can say. I hope I have answered your question, sir.
Sir. Thank you, sir.
Okay,
Thank you.
Yeah, which is efficient among GRU and LSTM? Yes, basically this GRU, that is popularly known as gated recurrent unit, and LSTM is stand for that is long short-term memory network, and both these network are nothing but the version of recurrent neural network. So basically this recurrent neural network and CNN, if we will compare this, the CNN are nothing but the feed forward networks, and the recurrent neural networks are nothing but having some feedback from the output to the input. So if we look into this GRU as well as LSTM, both are the advanced version or some version of recurrent neural network, and which overcomes the limitations of this recurrent neural network, that is vanishing gradient problems. So if we'll compare this GRU as well as LSTM, GRU has two gates, and LSTM has the 3 gates. So if we look into this GRU is having the update gate as well as the reset gate, and this LSTM has 3 gate, that is input gate, forget gate, as well as the output gate. So GRU doesn't possess any internal memory. They don't have any output gate that is present in case of LSTM. And in LSTM, the input gate and target gate are coupled by update gate in case of GRU, reset gate. So this LSTM is basically this reset gate in is defined by the 2 gates, that is input as well as target. So this both GRU as well as LSTM are the advanced version of this recurrent neural network, and I cannot say at this point that which one is more efficient, but both are advanced version of recurrent neural network, can be used for different kind of applications. like LSTM is used for arrhythmia detection or for the time series data. GRU can also be used for the time series data, etc. I hope I have answered your question. Dr. Sunanda. Yeah, thank you. So I hope there is any more questions in the chat box. I hope there is no more questions in the chat box. This is the right time to take a break. So at sharp 2 o'clock, Professor Vidyasagar will take the session. We'll meet at 2 o'clock. Thank you all.